Ever think about how something we experience all the time down here, like a lightning storm, could cause some serious chaos in space? Get ready, because today's deep dive is all about that.
We're talking killer electrons, lightning strikes, a cosmic pinball game. It's happening right above us.
And the craziest thing, it all starts right here on Earth. But let's break this down a bit. This article from space.com keeps mentioning these killer electrons and something called the Van Allen radiation belts. What are we dealing with here?
Picture two massive, invisible donuts of energy that surround Earth.
Okay, I'm picturing it.
Those are the Van Allen belts. Essentially, they're like magnetic zones created by the Earth's magnetic field. And they are jam-packed with these supercharged particles, including these killer electrons, which are zipping around at incredible speeds.
Killer electrons, huh? That sounds kind of ominous.
They're powerful little things. We're not talking about your average, everyday electrons here. They're more like tiny speed demons moving at almost the speed of light.
Wow, okay, so we've got these super speed electrons trapped in these belts bouncing around. What happens if they actually collide with something, like a satellite? What kind of damage are we talking about?
You've got these incredibly high-energy electrons smashing into a satellite at unimaginable speeds. This can actually create a burst of energy, like a miniature lightning bolt, that can fry the sensitive electronics on board.
Oh, wow.
Yeah, disrupting communication, navigation, all kinds of things. And in some cases, it can even completely destroy the satellite.
That's a little unsettling to think about, especially with how much we rely on satellites these days for, well, just about everything.
It's a real concern. It's a big reason why scientists are working so hard to understand these killer electrons and figure out how we can protect our technology in space.
Okay, so we've got these powerful electrons just whizzing around in the Van Allen belts.
Mhm.
But what's the connection to something like a lightning storm that's happening down here on Earth?
Well, this is where things get really interesting, actually. You see, for a long time, we kind of thought about space weather as being, separate from Earth weather. But this new research from the University of Colorado Boulder really shows that they're more connected than we thought.
So how does a lightning bolt here on Earth affect something that's so far away, like up in the Van Allen belts?
It's all about the energy, really. When lightning strikes, it unleashes this surge of electromagnetic energy in the form of radio waves.
Okay.
And these waves, they travel upwards, and some of them, they actually reach the Van Allen belts.
So those radio waves, they can actually interact with these killer electrons.
Yeah, absolutely. Think of it like a pinball machine, right? You've got the radio waves acting like someone who's coming up and bumping the machine,
Mhm.
and it gives just enough of a nudge to those electrons that are kind of trapped there, just enough to break free.
Well, that's a good analogy. I like that. So the lightning strikes, send these radio waves up, they hit the Van Allen belts, and boom, you've got these killer electrons on the loose. What happens then? Where do they go?
Well, some of them actually get channeled down towards Earth's atmosphere. Scientists call it electron rain.
Electron rain, it sounds kind of peaceful, actually,
Yeah.
for something that's potentially destructive.
Right.
So what happens when this electron rain actually, like, hits our atmosphere?
Well, it's not like you're going to see some, visible downpour or anything.
Okay.
But these high energy electrons, they can interact with the gases in our atmosphere. It can potentially disrupt radio communications, and it can even pose a risk to, astronauts and spacecraft.
Oh, wow. So speaking of astronauts then, what kind of risks are we talking about here?
Well, even though the Earth's magnetic field provides, a pretty decent shield, some of these energized electrons can still penetrate through, particularly in the polar regions where the field is kind of weaker. And this can be a radiation risk to astronauts,
Right.
especially those who are on spacewalks or, on future missions that are going to venture beyond Earth's protective bubble.
So this isn't just a theoretical problem. These are real, like, tangible risks that we have to think about with space exploration. What are scientists doing to address these challenges? What can we even do?
Well, scientists are constantly monitoring space weather. They're trying to develop better forecasting models. The goal is to be able to predict these electron rain events accurately so that we've got enough time to take precautions,
Mm.
like adjusting satellite orbits or delaying spacewalks if needed.
So it's almost like we need to start thinking about space weather forecasting, same way we think about, checking the weather forecast here on Earth.
Yeah, exactly. And just like we check the forecast before heading out, future space travelers, they're going to need to be just as aware of space weather conditions before embarking on their journeys.
That's wild. It's incredible to think that something we experience so commonly here on Earth, like a lightning storm, can have such a huge impact on the space environment.
It really does highlight how interconnected our planet is with the cosmos. It's not two separate entities.
It really makes you wonder, what other invisible connections are we missing out there?
Absolutely. And how much more is there to learn about, the link between Earth and space?
So much more.
Yeah.
Okay, but zooming back in, what does all this mean for us? Like, what are the long-term implications of this whole killer electron discovery?
Well, for one thing, it changes the way we have to think about designing and protecting our technology that's up in space. We
Example.
have to build more resilient satellites and spacecraft.
Ones that can withstand these electron bombardment.
Exactly. And when we think about future space missions, especially those that are, venturing beyond Earth's magnetic field.
Right, because that protection's not always going to be there.
Exactly. That's a huge thing to consider. We're talking about developing new shielding technologies and strategies altogether to protect our astronauts from this invisible threat.
Yeah, because it's not like you can just,
Oh, right.
swerve to avoid it.
Exactly, exactly. But we can be smart. I mean, maybe we're talking about like specially designed shelters within a spacecraft
Mm.
or even those predictive models we talked about, being able to say, okay, there's going to be a particularly heavy electron shower here, so let's adjust our course.
Sounds like we need a whole space weather report.
Yeah, exactly. A space weather forecast, just like we have here.
That's wild. So to wrap this up, who knew that something as simple as a lightning bolt could unlock so many mysteries about space?
Right. It just goes to show that the universe is full of surprises, and I think the more we learn, the more we realize how much more there is to discover.
Definitely. And that's what makes these deep dives so fascinating. Until next time, everyone keep looking up and keep those questions coming.